Okay, so the spring is changed so the frequency of the oscillation is doubled, right? Without changing the amplitude of the oscillation. Using the axes, sketch a graph to show how the induced EMF on the coil varies with time when the frequency of oscillation is doubled. The coil is at its equilibrium position when t is 0. You should give suitable values on the y-axis, right? Well, remember it's like this, right? It's at its equilibrium position, right? So it's moving at the fastest speed when it's in the middle there, right? So if this is our magnetic field, remember that the derivative, if this is a sine, the derivative of sine is cosine, right? Okay, so it's going to be a cosine wave, and then remember that the formula is what EMF is negative n change in flux over change in time. Turns out, by the way, you can either have positive cosine or negative cosine, but the derivative of sine is just cosine, right? And since there's a minus sign here, this should be a negative cosine curve, okay? So this curve should be negative cosine. It should start low, go high, go low, right? Okay, if the frequency is doubled, then that means it's going to go through a cycle every half second instead of every second, right? Okay, so you're going to decide here's 0 EMF, right? Okay, and then here's the trick, and I don't know where this is in the data packet because they don't really have a formula for like generators, right? I'm just trying to find this. I don't think they do, like with omega and stuff. So electromagnetic induction. Yeah, I don't really have it there. So I guess we just have to get this from the concepts, right? So if the flux is equal to, what is it? It's B. So B, if B is some, thing like this sine omega t, right? Okay, then the derivative d flux dt is equal to B, and then the omega comes out front because it's the chain rule, and then we have cos omega t, right? So the derivative has the omega in front. So the important thing here is if we double the frequency, we're going to double the omega, right? So therefore we're going to double the maximum EMF, right? So in the previous question, in part A, the answer is about 0.31 millivolts, right? Is what I got. So that means that this amplitude here is going to be about, well, it's going to be twice that, right? So it's going to be 0.62. So I'm going to go 0.2, 0.4, 0.6. I'm going to say this is positive 0.6 millivolts, right? We have to put numbers on there, right? And then this guy 1, 2, 3 is going to be negative 0.6 millivolts. Okay, so take whatever you got for A and double it, and then say, okay, there that is, right? And then let's see, it's a minus cosine. This is going to be terrible, right? So it's got to be a little bit more. So 0.62. Let's see, each one of these would then be, oh geez, I can't even figure it out. But you just draw it, right? It's going to be a little bit more than that, right? So it's going to go, whoa, it's going to go up. I'm so sorry. And then it's going to go down like that, right? So this is negative cosine, then up and down like that, right? So it's got to have the voltage should be 2 times, the amplitude is 2 times, right? Okay, the frequency is 2 times. There we go. How you're going to remember that the changing the frequency doubles the voltage? I don't see it in the data packet. I guess that's just something you should know. I've never seen anything. This is a specimen paper. I've never seen anything this hard on the tests. So there it is.